Okay, this time we will talk about the mm, data trees. So this is a different way of storing the information, the datas in the data in the Grasshopper. But let's start again the same series. I'll go for a panel and just this is generally a list, or the list is also a branch of the tree. But anyway, I will copy paste this one twice. And now I will do something which is called graft a tree. I will take a list and graft it. And now I see that generally the view has changed and my list, which is here, starts to be a tree. Also the icon of the link, it has changed. When it's a list, it's 2 lines. When it is a tree, it's dashed 2 lines. Uh, Indexing, and generally, what is the data tree? There is a nice thing which you can in params use. There is something with the tree. If I will take the list, I see that this is data with 1 branch and 10 elements, because this is generally the address to the branch, and it's 00, and then you have 10 elements, because this is just a flattened list. If I will take this one, I see that I have 10 branches. In each branch is just then 1 element. If I will double click on it, I will see how this is looking compared to classic list. So in the classic list, generally you have one single point which says that in the branch with address 00, we have 1 element, which is a list of integers. So what is generally how you can imagine the data tree? This is just a story box, and to get the information, you need to have the address of your to the shelf on which you have the address for the box in which you have the information. This address is generally this number 009, 008. So this is an array of integers. Okay, let's try to operate on it again. If I will flatten it, I'll go for sets and go for flatten tree. I can again achieve the list. Flattening is always working on any kind of the branch, and it's generally creating out of the data tree a flattened a list. Quick way to do it is right click, and here you have a graph and flatten. So if I will click flatten, it will make a list. So why we generally use trees, why we are not using only lists? The quick and clever example is when we are producing point. If I will take x to this the series and connect with the x, we will have a list of points. And now I would like to connect it to the y to achieve the um, points with different coordinates. So x coordinates is just a flatten link, flatten list of integers. Y is the same because I take it from here before the graftening. So what he did, he make a list of points in which 0 he's taking from this series, Y series he's taking from this. So he's connecting first element to the first element from X list and Y list, and it is combining with it. What will happen if I will graft it, connect this list with the graften list? So what he will do now, he will take first element in the list which he found in this branch, and this is just 0, and he combined this y with 0 with all element if this in this list. So he generally then he goes to the next branch, he found number 1, and he combined this 1, which is here, with all the elements in the X panel. The outcome is still the data tree. So as you can see, it's generally exactly the same addresses as in this. Those addresses are a little bit strange because with every operation it's adding some zeros, and to make it more clear, you can always try to simplify it, and he will get the simplest address he could achieve. So the same here, 0, 1. So in this case, you can treat it as a two-dimensional array. And if it's a two-dimensional array, you can make some tricks about that. So if I will go for a polyline, for example, he make a polyline for each branch. What will happen if I will flip a matrix? I will take this one. I know that it has the same, it's working, this flipping of the matrix will now combine this first element in this list with the first element in this list. So you could imagine it as a transpose of the matrix. So in this scenario, I have the vertical and horizontal lines. Okay, yeah.